Hello everyone, in this series of videos we're going to show how to use the GRN Modeler app to create and characterize gene regulatory networks in silico. The app is particularly useful thanks to its user-friendly interface that especially allows to explore circuit topologies and guide experimental work. Then the user can refine the model thanks to the collected experimental data. First of all, let's get our application up and running. You can find the code of the GRN Modeler app on GitHub. You can, for example, download the zip folder and then extract it to your working folder. Keep in mind, to run the application, you will need MATLAB version 2022b or later. And some functions of the application become available only after downloading Python, Basico, and Copasi, but we will cover these in a later video. For the moment, let's just click on the GRN Modeler app. Before we can start designing a circuit, we need to select a node model. This basically defines the kind of interactions that can happen within our circuit. We have already implemented 5 node models, but users can add extra models based on these examples. So Elowitz and Tomatsu are based on transcription factor interactions, while Javier and CRISPR are based on CRISPR interference. Today we would like to show how to design a repressilator. So we need a transcription factor based model, and we would like to include degradation due to proteases. So for this we select the Tomatsu model. In the interface, we can start designing the circuit by adding nodes thanks to the node properties box. Note that a node here represents a regulatory unit, meaning a promoter followed by a gene that encodes for a transcription factors. If we don't specify names, the application will add nodes named n followed by the first available number, so node 1, node 2, node 3, but we can also specify a name. And if we try to use a name that is already existing, we will get an error message. If we realize we have an element we don't need, we can simply click on that and hit delete. We have 2 other elements in the node properties box. We have type. Type depends on the implemented node model. So in this case, since Tomatsu only uses transcription factor, we can only select type 1 here. And set we will cover in the next video. Okay, so now we have 3 nodes that is sufficient to build a repressilator, but we want to specify which kind of interaction is occurring between them. So for this we need the regulator properties box. We can select the regulator, meaning who is carrying out the regulation. And for this we can choose between the protein product, noted P, for each of the nodes. So I select PN1 here. Then we need to choose who is being regulated. 2. We can specify the input function. Here again, since Tomatsu model only uses transcription factor, we can only select HIL here. Consider the input function as the set of rules that define the interaction between 2 elements. So who is interacting with whom and how. Finally, we can specify the type of interaction, and this can be either an activation or a repression. Also, the app allows to distinguish between activation and repression if the interaction is carried out between nodes within the circuits, or out if the interaction is carried out by elements external to the circuit. So for example, chemical inducers. Here we want a repression between 2 nodes of the circuit, so we select repression in. And now we see that we have generated a new element, the regulation, noted by this yellow dot, and the label node 2 repressed by node 1. We add 2 extra regulation from node 2 to node 3 and from node 3 to node 1. And also note that here we can now start regulating a regulation, and this of course will make the circuit increasingly complex. Also, as mentioned, we can add external inducers, so we could have ARA for Arabinos, regulating an element. If we don't specify a name, in this case, the app will simply add R for regulator, followed by the first available number. As before, if we realize we have elements we don't need, we can simply click on them and delete. And for example, for the repressilator, we don't have these extra regulations, so we'll delete it. And we don't have any Arabinos induction. Keep in mind that if you have an extra node that you don't need, you can click on that and remove it from the node properties box, and this will also remove all the interactions that node is involved in. But if we try to remove R1, it will not appear in the node properties box because this is not a node, it's a regulator. So if we want to delete this element, we really need to click on the yellow dot and use the regulator properties box. Okay, so now we have three elements mutually repressing each other. We also want to include protein degradation due to proteases, and Tomatsu model allows, thanks to the third box, to add proteases. Again, we can add as many as we want, and we can also click and delete if we have extra, and we can specify that our protease number 1 is regulating also node 2 and node 3. Okay, so with these we have three nodes mutually repressing each other thanks to transcription factors, and all three protein products are subject to degradation due to protease. With this we're happy. This is the topology of our circuit. We would like to save it so we don't need to build it from scratch every time we open the app. So for this we go on input output, save it to our folder. We can give it a name. And once that is done, we can close our interface without losing the job done. In the next video, we will learn how to change the graphical settings of the circuit and also the parameter setting of our model.